Hello guys, Craig from Fix It Fallows, and I'm here today convalescing, to be honest. Bit of man flu, been watching loads of YouTube, and whilst watching YouTube, come across some mathematics and something in particular called the Collatz Conjecture. Collatz Conjecture. Now, in this mathematic problem, it is proposed that if you take a number, any number, and apply the equation 3n plus 1, eventually whatever number you started with will come down to 1. And very learned people have spent a ridiculous amount of time studying this, trying to prove it or disprove it, and supposedly they have researched numbers up to 2 to the power of 68. So you're talking like nearly 3 quintillion or something like that. And when you apply 3n plus 1 to any number in that range, it will always come back to 1. But people seem to be obsessed with the fact there must be a number out there that doesn't follow this rule. Right, okay, so let's go through an example of how this works. Let's take any number. Let's take the number 7. Okay, we apply 3n plus 1. So 3n means 3 times the 7. So 3 times 7 equals 21, and then we have to add 1. Plus 1 equals 22. Then the rules are, if it is an even number, then we have to divide that number by 2. Okay, and that equals 11. Okay, when you come across an odd number, you then reapply 3n plus 1. So we're over here to 11. 3n plus 1, 3 times 11 is 33. Plus 1 equals 34. Okay, so we're back to an even number, so we divide that by 2, and we now get 17. So we do 3n plus 1. So 3 times 17 is 51, plus the 1 equals 52. So, even number divided by 2, okay, gives us now 26 is an even number, so we divide that by 2. And that gives us 13. So we're going around the houses here a bit, but we'll carry on. 13, odd number, so 3n times 1, 39, plus 1 equals 40. It's an even number, so we divide that by 2. We get 20. We divide that by 2, and we get 10. We divide that by 2, and we get 5. Back to an odd number. So 3n plus 1, 3 times 5 is 15, plus the 1 equals 16. Now 16 is an even number, divide that by 2 equals 8, another even number, divide that by 2 equals 4, another even number, divide that by 2 equals 2, and then 2 is an even number, divide that by 2 and equals 1. So we've got back to our number 1. So 7, when you apply the 3n plus 1 rule, comes back to 1. Now it's been found, or basically it hasn't been found, that they can't find a number that when you apply this 3n plus 1 rule and the odds and evens and whatnot, always comes back to 1. They can't find one that doesn't come back to 1. And I say, well, what's all the fuss about? Really, what is all the fuss about? And let me explain. So, in all of these examples, to get back to 1, you have to keep dividing by 2. Now, there's only certain numbers that when you divide by 2, gets back to 1. Now they are what I would call, how do I express that? It's like a geometric sequence, isn't it? So 1 plus 1 equals 2. If you take the 2 and add itself to itself, you get 4. If you take the 4 and add 4 to itself, you get 8. And 8 plus 8 equals 16. And so on and so on. 16 plus 16 equals 32. And 32 plus 32 equals 64. Then it goes 128 and 512 and 1024 and 2048. And so it continues on infinitum. You can continue this sequence on forever because there's always more numbers, right? And all you do is just double up what you've already got. Now it's only these numbers that you can keep halving to get back to 1. Not all even numbers do this. Okay, so fundamentally you have to hit upon these numbers to get back to 1. So my argument is, the only special thing about this whole formula is getting to this geometric sequence, and then you keep dividing by 2 and you get to number 1. So you could pick any number you care to imagine, let's say 27, and then apply 3n plus 1 to it. And the fact of the matter is there's no rules about how many times you apply the 3n plus 1. So if you do 3n plus 1 sufficient number of times, eventually whatever number you started with will fall upon one of those numbers in that geometric sequence that I've found, or not found, that I explained. So where's the great mystery? You know, you just apply that enough times and randomly you'll hit upon a number that can just be continuously divided by 2. There's no magic to it. There's no massive explanation needed. There is no number out there that cannot be divided down to 1 if you apply that algebraic formula to the number sufficient number of times. Guys, mathematicians, focus your energies on something else. Just saying.